I'll get to the first question that we had, and this is from my friend Hank. And I'm not sure if Hank's watching because we actually have um, we normally have it's part of our church men's huddle that we have going on right now. So he's probably at that, but
Oh, nice.
it's all good. I want to get a picture that he sent me up here
All right.
and show what he's got going on at his house. So give me 1 second. I'm gonna pull this up. So let's see here. And I'm going to see if I can share my screen actually so we can see this together. So I'm going to show this whole screen. Chrome tab, this window, share this window, go here. All right, can you see me?
Yeah.
All right, pull this over here. All right, so here's Hank's question. He's got a mechanical room inside of his garage. Last summer, he started noticing a bunch of black mold growth on the drywall, exactly where the ductwork is, branches, but it's only in the garage. He thinks it's from condensation. Kids keep the door open all summer long. One additional worry is that his furnace vent stack on the roof has not had a cap in over 2 years. Do I need to rip out the drywall and better insulate the ductwork in addition of getting a proper fluke roof cap? And here's the picture. So this is above, looks like the furnace door. And this is looks like the trunk line going through the garage. You can see that.
I'm not seeing that photo. Seeing a
Uh,
whole lot of YouTube windows.
oh my gosh. Let me see if I can figure out why you can't see the window.
But I've got a pretty good, just from the word picture he painted, it's a pretty common problem.
So let's try this a different
Unfortunately.
way. The entire screen. Let's see, screen 2, share this.
It'd be a great visual.
There, that. Can you see that?
Oh, yeah.
Yeah, so his garage is kept open pretty much all summer, sounds like, from sports activities with the kids, and
Hmm.
this is what's showing up on the drywall.
So if that is indeed the M word, which, it'd be hard, you'd have to measure it to tell, but in the past summer that we had with such high dew points, any exposed metal or any duct leakage, the dew point of if they're metal ducts or even flexible ducts, those will reach dew point and they'll start to drip. So if it's showing on that side of the drywall, there's no telling what it looks like on the other side.
that's kind of what I was thinking. I don't know how old the house is. He didn't really tell me that, but I'm guessing I'm going to guess it's at least 20, 30 years old, maybe older than
Yeah,
that. But the ductwork may not be insulated at all
it may not.
in that case. And so if you've got a main supply trunk line going through the garage like that and it's feeding a room above there and it's not insulated at all, it's definitely going to sweat. I mean, the hotter
Yep.
that you make that garage, and then depending on what the air temperature is, no matter really what the air temperature is, I mean, typically the air temperature coming out of an HVAC system is in the 50s,
Hmm.
mid 50s or something like that. So if it's 80 or 90 in your garage, you're definitely going to have sweating ductwork. I guess it's too bad he's not on the call itself right now, but I would love to know if he's seen this. If this is a recent issue, like if he just
Right.
saw this in recent times, or if this has been ongoing for a while. Because if it's recent, it might also be an issue with the HVAC system. Like if he has
Yes.
reduced airflow or something because he's using a restrictive air filter. Um, any other thoughts on that?
Yeah. Anytime that you bring up a great point, anytime that a problem like this, if it's ongoing, then you can start to back into and reverse engineer what's going on. But if it's something that all of a sudden happens 1 year from to the next, then you got to ask yourself, okay, what changed? Did the HVAC equipment get changed? Did the weather change? What changed from say last year to this year, 2 years ago? Did you replace your windows? There's all kinds of things. Did you upgrade your filter, as you mentioned? There's so
Mhm.
many different things that could go into it.
Yeah, so he's got those pictures, and then the other question was about, I guess, so the answer is like, do I have to rip out the drywall to fix this problem?
Well, there's already visible signs of moisture, so some work's going to have to be done. The challenge with that is if you start randomly ripping it out, if it is indeed mold, those spores are going to go everywhere.
Yeah. So making sure that you've got this sectioned off from your house and you're not circulating this throughout the house would definitely be a concern of mine. It looks
Yeah.
like you also have a main support beam right here that's going through that this bulkhead. So I'm guessing the ductwork runs along this side, and then you've just got extra space over here. There's probably not ductwork on the other side of that beam. But yeah, Hank, I would say you're probably going to have to take the drywall out here to see if the ductwork needs to be sealed and insulated. And then if it does need to be sealed, you're gonna want to do it the right way. So like, don't use duct tape. Duct tape's not for ductwork. You want to use a UL 181 rated tape, or duct mastic is the best thing to do. But the other challenge might be, depending on up here, like if the ductwork goes all the way up to the floor joist up here, getting insulation all the way around the ductwork might be a challenge here. But one way or another, everywhere that there's a strap connecting two pieces of this trunk line together, that strap, that connection right there needs to be sealed with metal tape or duct mastic. Duct mastic, I think, is probably a better long-term solution. But if you use the metal tape that's got the butyl adhesive backing to it, that's really thick, that will generally last longer. Any other thoughts on like the type of insulation he should use?
It would have to be something that's external, which is of course best. But looking at where some of that condensation is, it looks like not only is it, underneath that chase there, but also over at the edges of the walls, which would be where the boots are. So I think one of the things, the insulation is going to help, but stopping that condensation getting in there. And I go back to the, if this is indeed mold, because we don't know without testing it. That exterior wall there, I would just about bet there's like a takeoff or something there, a boot, some bare metal, that when those garage doors are open, that surface, that moisture is actually moving through that drywall and then coming into contact with that metal,
Yeah.
and reaching dew point.
Yeah.
But if it is indeed mold, I would be concerned about, keeping the spread of that down, because that could really open up. If you start going in there and just ripping out drywall, it could create a whole host of problems.
Yeah.
So it typically it's going to go beyond the scope of what any HVAC professional can do, unless they've been certified in that.
Yeah. And the
But
reason
at the
why
same,
David's being averse to saying that this is mold is because, as an industry, we're supposed to call it microbial growth until you've actually tested it and
Yeah.
know what that microbial growth is. You don't want to freak people out. It's obviously a concern. It's an indication that something is happening up there, but that's why we're not going straight to that term.
yeah, we simply don't have enough information. I mean, but there's definitely something going on.
And then the second part of his question here has to do with the vent stack on his roof. And this isn't the best picture, but I think that is his HVAC pipe right there, and it does not have a cap on it.
Wow, that definitely needs a cap on it. So if he's got a furnace in his house, the other thing to look at is, has the furnace been combustion tested to ensure that it's safe? Because there's no telling what could have gotten down in that flue, and depending on whether that furnace is common vented or tied in with a water heater in his garage, the flue gases could actually be spilling out into his garage. So there's a couple of different scenarios that could go on there, but that absolutely needs a cap on it.
So what happens, David? Like if there's not a cap, this is a metal flue pipe right here. This isn't a PVC pipe. It doesn't look like it. Looks like it goes to like an 80% gas furnace or an older water heater, an atmospherically vented water heater. If there's not a cap on there, you're going to get water coming down the flue pipe,
Yeah.
which eventually is going to leak out somewhere inside the house, right?
Right.
So I'm also wondering if this flue pipe might be going through the same bulkhead in the garage.
There is a possibility. It's not ideal, but a lot of times those vents will run horizontally in those chaseways and then go up through a vertical chaseway to where they can go outside.
Yeah. So the answer to Hank is yes, you definitely need to have a cap on this. I think the second question is, what appliance is this attached to?
Yeah.
And I can talk to him later about, the connection between the roof and that appliance, and does it actually possibly go through that bulkhead, and help him figure that out.
And
This
making
Hank's
sure
local to me,
also
so-
with it being a gas appliances, he's got ideally a low-level carbon monoxide monitor in there to protect his family. At the minimum, a carbon monoxide alarm that you buy
Yep.
over the counter, because they're two totally different things, but at least you would have some level of protection if there's nothing in there right now.
Yep, for sure. Okay. All right, let me back out of here. Stop sharing that so we're not all duplicated. We have another question here from Tom Wilson in the chat. If you have a heat pump water heater in your basement in a cold climate zone and it's well insulated and with well insulated sidewalls and a floor slab, where does the heat pump get its heat? It has to be made up somewhere.
It's pulling it from that space of the ambient air that heat pump's installed in. Now the challenge with that, because there's heat all the way down to 460 degrees below zero. So, heat pumps are going to be very efficient. They'll pull that heat. But the problem that you may run into is it may get very uncomfortable in that basement because of the cold discharge air.
Yeah. Yeah. So is there a way that he could pull the heat maybe from a floor above and bring it down to that heat pump?
You might be able to create like a closet around it in the buffer zone and actually put a duct into it, so that, say, when your traditional HVAC system's running, it actually pumps the heat into that space and it's not pulling from a gigantic area. So
Yeah.
that might keep the communication down on it
Yeah.
with the rest of the house.
I'm just also wondering if there's another place in the house that he could move it to that would be in a more in a warmer part of the house.
Yeah, because it is the cool air that offsets, because it is discharging the cold air as it's pulling heat from
Yeah.
the surrounding air. It's now granted, it's kind of neat in the summertime. It's kind of nice, but wintertime it might get a little uncomfortable.
Yeah. I mean, the nice thing about heat pump water heaters is if you're in a hotter climate, I mean, you could just put it in the garage and all summer
Yeah.
long, or you could put it inside the house, obviously, and it would help cool the house, but at least you're getting heat all summer and all winter long in a hotter climate. Um, do you want to touch on any of the other kind of like, pros or cons of heat pump water heaters in general? Because it's been a kind of a hot topic over the last
It
10 years or so.
it has, and a lot of it's been reliability. So I think, if you have one, do your research. If you don't have one, do your research before you invest. I know with any heat pump, maintenance is going to be the top thing. It's not one of those. It's not like a refrigerator. You don't just slap it in and leave it. Any type of heat pump, you've got to make sure that they stay clean. That's going to degrade the performance of any heat pump, especially a water heater, more than anything. The other thing I think you should pay attention to is your water quality. Depending on what part of the country you're from, uh, Eric and I are from Kentucky. We've got, lime. You'll get scale in a water heater within 2 years. So if you don't have a way to keep your water quality controlled to keep that scale from building up, I would look into that also. So there's two
Yeah.
different sides. You've got the air side and the water side that you need to maintain for cleanliness to get the
Yeah.
best efficiency out of that heat pump water heater and longevity.
Are you aware of any brands that are better than others? Because I mean, General Electric for a while, and I don't know if they still are, they were making them in Kentucky, in Louisville.
Yeah.
And I know that they had some issues early on and they kind of tweaked the models. And then there's A.O. Smith and Rheem, and there's a bunch of different models out there.
Yeah.
Don't know if you have any personal experience with them.
I do not. I know that they've all had their problems and they've all got ones that work great. That's why I think you should do your research before you just go to your favorite store or deal with your favorite plumber and just buy based off of their experience. Look, do some research and find out especially with their warranties and any pre-existing problems, any version changes that have happened to that equipment is also going to be a pretty good tell. Or if one just disappeared off the market, that's also another telltale sign that you probably
Yeah.
don't want to deal with that model.
Yeah. Let's see. Tom has a follow-up question. I'm going to put it on the screen here. So whether it comes from the basement or the house, if it is a closed system in the winter, the heat has to come from somewhere, which means you space heat system to provide that.
Yeah, I mean, if you've got just a standard heat pump system that the heat pump itself sits outside, I mean, cold climate heat pumps will maintain 100% capacity down to, I think it's like 5 below or something like that. So if you've got a basement that's, let's say on average running 50 degrees, you'll still have plenty of heat to pull out of that basement. So if you've got a high thermal mass, the temperature may drop a little bit, but I mean, you start dropping below freezing or something, you're going to have a whole lot of other concerns than that heat pump water heater. I mean, you're going to have plumbing freezing. So
Yeah.
I think, and as we said, you could take, if your mechanicals are located in that same basement, you could put a supply register down there and a return to partially condition it.
Yeah, I guess, Tom, I'm not clear if the basement's actually finished or not, or if this is just like your mechanical space, but if you've got bedrooms down there, that's another thing to consider. So if you could pop that in the
Yep.
chat, that'd be nice to know.
That'll help us.
Back to the mold question, Pierre actually had a question. If it's not mold, what would it be?
It could be dust and dirt. There's a principle known as smudging. When you've got dirt moving through the air, if it's moist, it will stick to surfaces. So that's, it could just be dust and dirt.
Yeah. Either way, it doesn't look good, and you don't want it to go on your drywall because it's going to continue going on with it.
It doesn't. Now, here's a prime example of this. You'll see this many times where in HVAC systems are in attics. If the boot penetration, where you've got your supply register, sometimes they're called vents, if that's not sealed, there's a principle called entrainment where air comes out of the supply register. But if it's a dusty environment, the dirt will stick and smudge to that. And I guarantee you've probably seen it in commercial buildings. If you go into any restaurant and you look up, they have what are called 2x2 diffusers, and you'll see dirt kind of smudged across the tiles. That's not mold, that's dirt.
Yeah.
Go into your favorite big box store, Home Depot, Walmart, whatever. And if they have any trunk ducts run, look at the joints that are unsealed. You'll see dirt around those as well. It's the same principle. So that's why you have to be very careful about saying, oh, it's mold, because it could just be dirt. But either way, like you said, Eric, there's something else going on there.
Yeah, and that same thing where you see the air coming out around the supply vents on ceilings in attic spaces, especially if you have old dirty insulation up there, that's the dust from your attic that's basically leaking out between the gap. If you took the register off the ceiling, there's a metal boot on the ceiling, and there's a gap between the drywall and that metal boot, and that's where that dust and the dirt is coming through. And in new construction, that is required to be sealed you basically won't pass code from the duct leakage code if you don't seal that gap between the boots and the drywall. So if you go into an older house and you see that, that's like immediately just take the register down. You can use either silicone or a good metal tape to bridge the gap between the boot and the drywall, and just make sure the tape doesn't like extend further than the register and you're looking at silver now on your ceiling.
That's a simple fix anybody can do with the cheap materials.
And it'll push more conditioned air into the room that's in, right? So it's not leaking up into the attic, because that's really what's happening is you have air from the attic moving through there, but a little bit of the air through the ductwork is also moving through that connection.
Right.
So let's see here. I got another question from R2 Dork. It says, thoughts on ventilation in hot, humid climates during summer? Ventilating dehumidifier or ERV or something else? I've done some searching, but there doesn't seem to be generally agreed upon answer.
We actually discussed this not too long ago. You're right. There isn't a consensus on it because there's so much that gets into it. You need to be ventilated because ERVs, they say they have moisture removal capacity, and they do to a certain extent, but they're not a true dehumidifier. So I think a lot of it depends on what the capacity of your existing heating and cooling system is, how much moisture removal it has. If you've got older equipment, a lot of times the existing capacity of the equipment could handle the moisture removal. But if you have a hot, humid climate and you've got a fairly new heat pump, they don't remove as much moisture in some instances. So that's where you will need to supplement that with something that can get rid of the moisture, and a dedicated dehumidifier may be your best choice.
Yeah, a ventilating dehumidifier. Yeah, we talked about this a lot just a month ago. And we can go down and talk for the next 45 minutes about dehumidification and oversized air conditioners and bath fans running constantly, and there's a bunch of reasons why you might have high humidity in a house. So I think you need to take a step back and look at the bigger picture about why you might have high humidity in the first place in the house.
Where is it coming from?
Is it coming from the outside due to air leakage in the house? Do you have a bunch of recessed lights like we've talked about where those are leaking, and that's bringing in hot, humid air from the attic into the house? A lot of people will be quick to blame windows and doors for that issue, and it could be, but usually it's not the biggest problem. It's usually not the biggest leak in your house. So, attic hatches are a big one. Bulkheads that are open to attic spaces. We talked about the top of laundry chutes a lot of times will be a source. So in general, air leakage in the house is going to be the biggest driver, and then duct leakage. So if you have any ductwork that's outside the living space, especially like in an attic, a garage, or a ventilated crawl space, any kind of like duct leakage, especially on the return side, will draw air into that system, circulate it through your house. So I guess the point is, don't just go buy an ERV or a dehumidifier before you address the air leakage, the duct leakage, and these other things first.
Yeah. And that's assuming, I don't know if you have a humidity issue or not, but I know years ago, I trained a couple of guys up in Wisconsin that had called me and they were like, "You're not going to believe this." We had a customer calling and they wanted a dehumidifier. And we were like, "Well, let us come out. We'll take a look first." And they had a crawl space and there was standing water under it.
Oh,
So
wow.
you got to take care, like you said, Eric, you got to take care of the moisture source first. But
Yeah.
if you're just looking at options, there's, not to sound snarky or anything, but there are a lot of other factors that it depends on if you're just looking at ventilation and making sure that you've got some other details taken care of first.
Yep.
Because otherwise you may get a dehumidifier and you didn't get rid of the source of moisture to begin with that you needed it for.
Yeah. In my online course, I talk about you really need to prioritize by taking care of, like you said, the bulk water issues first. So if you've got uh, gutters that are missing or damaged and it's just dumping water right next to your house, or you have downspouts that don't have extensions pushing the water far enough away from the perimeter of the foundation, like that's the first place to start. You want to make sure that any water and that you have a negative grade away from your house. So like if you've got dirt like this next to your foundation and every time it rains, it just pools right next to your foundation, like no amount of dehumidification is going to fix that issue. So
No.
fix the grade, make sure your downspouts come down, water comes away, and then the vapor barrier in the crawl space would be the next thing after you fix the bulk water issue. So ventilated crawl spaces are notorious for moisture issues. They are generally not something I recommend anybody install ever in a new construction house. And if it's in an older house and you don't have these grading issues, you need to seal it up. You need to take care of the vapor barrier, insulate it, encapsulate it if you can afford to do that. So there's just a lot of things. But if you are interested in the course, it's myhomecomfortadvisor.com. You can learn more information about that. Let's see, I got another question in here. This is another one from Tom. And this says, not a specific situation, but theoretically, a heat pump water heater in a closed system will add to your heating load. So you are just robbing heat from one system to feed the other. I get what he's saying.
Yeah.
Yeah. And that's legitimate. So, the other thing that you can do with heat pump water heaters is you can actually send that cold air out. So you can connect a duct to it and you can send it out of the house so that it's not just dumping back into the basement. So that is another option for you.
And I've heard rumors, I don't know if they have them on the market yet, but actually split heat pump water heaters, so they would have an actual dedicated outdoor section with refrigerant piping in between. I'm not for sure if those have actually come to market yet, but that's something that has been discussed and explored.
Yeah, that'd be a good option for sure.
Yeah. I think the installation cost would go up, but if the reliability's there, it'd be a good option.
Yeah. So this is a follow-up to the ventilation questions. It says humidity gets to 56%, I assume, or so in the summer, mainly thinking about ventilation, higher CO2 at times.
Yeah. So if your CO2 levels are getting up, that's going to be a good indicator that you could actually improve your ventilation. CO2 is a great indicator of leakage
Yeah.
and air changes.
All right. Let's see if we got any other questions yet. Luke was poking fun at you. He says, I was going to get David's thoughts, and I don't know on what there. It's Luke Peterson. If you've got a question there, Luke, let me know. I did have another one in my email, and I didn't get the full picture of it. Let me see if I can.
Yeah, pictures are great. They add a lot of detail because sometimes we have to assume based off of the information that we're getting.
Yep. All right. So my friend Matt locally sent me a link to Company Cam. Don't know if I can do all this stuff right now. Hold on a second. Hold on a second, Matt. Let me see if I can get this up. When's your next training with NCI?
Let's see. I was supposed to go to Tennessee next week, but actually someone else is going to do that. We've got a combustion class, carbon monoxide and combustion performance class coming up at our headquarters in Tennessee next week. So that, I don't think I'm actually scheduled to do any public classes. I'm speaking at the Duct Cleaners, NADCA, the National Air Duct Cleaners Association. I'm speaking at their annual conference the end of March. And then, let's see, calendar. And then I've got a private class out in Craig, Colorado, the elk hunting capital of the United States, first week of April. So, and actually going to some training myself the first week of March, if everything holds true and makes with the classes. There's one of our partners is a software company called MeasureQuick, and they make some incredible software for HVAC companies where they take wireless probes and smart instruments and they gather all the information, do a whole lot of calculations.
Yeah.
And they make life so much easier. But they're actually hosting a class here in Kentucky over in Versailles that I'm going to attend.
That's cool.
So lifelong learner.
Okay. All right. I've got another question here. And this is from Matt from Louisville Insulation. And let me see if I can get this over here. Let's share this. And I'm going to share this screen here. All right, let me know if you can see that.
Yeah.
Okay. So it looks like this is a garage in the back. It's going to be conditioned space. And he's got a duct system that's going through the attic that's directly above the ceiling joist. So he's got a 5-inch air gap from the top of the drywall to the bottom of the duct.
Okay.
Recommendation is to spray this tight area with closed cell foam on the first trip out due to potential condensation issues down the road. I would say that that's a good idea, especially because they're using bubble wrap insulation.
Yep. Absolutely.
I don't know if you want to talk about bubble wrap because
yeah. It bubble wrap has what is called there's two different types of R values with duct insulation. And with any type of insulation, you have what's called a rated R value and what's called an effective R value. And with bubble wrap, there's a rated R value, but the effective R value tends to be much lower unless all the installation details are hit just perfectly. And one of those depends on a dead airspace and spacers of that in between underneath that insulation before it's applied.
Right.
And many times those spacers are not installed. It's just applied directly to the metal. So that dead airspace is non-existent. The other thing is the ducts would have to be 100% airtight, because if there's any leakage underneath that insulation, it'll act as a secondary duct, and then the air will just move back and forth, and it creates what's called a convective loop in there, and it just transfers heat on the opposite side of the insulation against the ducts, and that's where that condensation will start to set up. So putting that closed cell in there.
Yeah, you can start getting some water dripping out of that Reflectix too.
Yes. And that's a possibility, like your other photo that your friend sent. That is a good possibility. That's what's happening in his situation. So if you could imagine this duct system on the opposite side of that other photo, that may be something very similar to what you're seeing.
Yeah. I wonder if I can potentially.
So, I mean, bubble wrap will work great if it's installed according to the manufacturer specifications, and the devil is in the details on that.
I wish I could zoom this in. I can't zoom in on the picture for some reason. Feel better about the flux under here. So what do you recommend to do in this situation? Let it ride, point things like this out, and immediately become the highest bid. This is fine. I don't see why you're asking other questions above. Yeah.
The first thing I would want to know is where's the design for it?
Yeah. Is there a design for it?
Is there a design? That's where the rubber is going to meet the road on this. How did you get your design? And if they're using some type of a rule of thumb like 0.10 or this size flex duct gives me so much air, red flag.
Yeah. In general, I mean, I see this Reflectix stuff used all the time. This looks like it's actually the R4 and not the R8 bubble wrap. So in our climate zone, you have to have R8 duct insulation to pass code. And what I've seen a lot of HVAC guys do is they'll just put 2 layers of this stuff on and they'll call it good for R8, which again, there's no air gap between the duct and the bubble wrap. So doubling up on top of the sheet metal directly is not going to give you an effective R8.
No.
You know, the better thing to do, Matt, is, you know, if he would just remove all this bubble wrap, you could just spray closed cell directly to the sheet metal and to these collars that are on the flex duct, and that would seal it really well together and insulate it a lot better than this Reflectix that you got right here. The other question he had here is, this is a common issue, climate zone. In this climate zone of the project, do you want to baffle the entire run or every 4 feet? I get mixed opinions on this. So he's talking about attic ventilation coming through this right here. You know, I think if you're putting fiberglass across the top plate, you're going to get air movement that comes through the fiberglass. If you were going to spray foam and seal that off, then I would definitely baffle every single one of them. But I guess the question is, do I put a baffle here, a baffle here, a baffle here, or do I put one baffle in every single one of these chutes? So I think it depends on what you're doing with the soffit as far as the insulation.
Yeah. I agree with you totally.
Yeah. So I don't know how much more it's really going to help, and I think there's a lot of debate or misunderstanding about what the purpose of attic ventilation is for in the first place. Some people think it's just to make the attic cooler, and really, I think it's just to get the moisture out of the attic in the first place that may get in there. But any moisture that gets in the attic in the wintertime is going to come from the house itself. And so this is kind of it's really a different scenario, but any air leaks that you have or heat loss that happens from the conditioned space up into the attic, that needs to be addressed first. But in this situation, you also have ductwork that's creating heat. So if it's not sealed and insulated properly, it can create condensation. But that ventilation into the attic is really to get moisture out of the attic.
And I guess it begs another question too, going back to the original question about putting the closed cell foam underneath, is if this is going to be an unconditioned attic, and there's a second type of insulation that's going in there, that's not going to keep the ducts from sweating. It'll just sweat above the closed cell and then condense on top of it. It'll just be the first surface that it hits instead of the drywall.
Yeah.
So the ducts could technically still sweat as long as the temperature in them's at or below dew point.
That's a good point. I'm not sure if there's any other questions in this thing or not. Nothing here per the customer above grade. Well, if that's an exterior wall, then technically that should be insulated. Concrete has an R value of about about R1, frankly, for 8 inches of concrete. So I would put a 2-inch thick piece of foam board on there at minimum, if you're not spray foaming anything else. And all these connections, so all these collars need to be sealed. So hopefully that answered your question. And then as far as insulating underneath there, I definitely think that it would be a good idea to foam underneath there. The only problem, again, is if there's any duct leakage happening and that water, if any condensation happens, it'll drip out into the open cell and then absorb into the open cell over time. The same thing would happen with cellulose as well.
Yep.
And then potentially materialize on top of the drywall. So hopefully that answered your question there, Matt. So I'm going to stop that one. We have another couple questions. Let's see here. On split and latent and sensible load. I'm not sure if Luke was talking about. Luke says he's going to be at your class here coming up soon.
Oh, cool.
Let's get David's. I wanted to get David's thoughts on split and latent and sensible load.
That could go a whole lot of different ways. It's going to depend on the equipment. One of the things that I have noticed is when you start looking at the side discharge units, it seems like they've got better latent capacity than systems that have, maybe from like 3 or 4 years ago. Now, I have not looked at the specs lately, but the last time I did, it looks like they're actually doing a lot better on the latent. The key with that, of course, is going to be sizing. My colleague Adam Muffich always says if you install an inverter-based heat pump, or an oversized inverter heat pump is the most expensive single stage equipment you can buy. It's still, even though you're dealing with inverter based equipment, still got to be sized right, but
Yeah.
it's got to run. You're trying to match the load, and of course, if you're doing a load calculation, it's only going to 95% of the time it's going to be oversized anyway, even if it's properly sized, because you'll only get design conditions around 5% of the time. But still, that you could go more in depth on that, Luke. I'm not for sure which direction you want me to go on that. But,
Yeah, I mean, that's a great point in itself, though, because a lot of HVAC companies will sell these inverter-based systems and say that you can't oversize them because they ramp down to, say, 30% of the output. So even if the heating and cooling load for the house is, say, 3 tons, and they put in a 4-ton system, they're like, well, I'm giving you extra capacity and it'll ramp down to a lower amount when needed. But at that lower amount, it doesn't provide the same dehumidification as it does at the full amount, right?
yeah.
So,
Yeah, and there's other issues that no one talks about, like oil return to the compressor, longevity. There's a lot of other things that don't get mentioned. So, yeah, make sure when someone's, for any homeowner on this, make sure it wasn't even an HVAC guy. If you're going out and matching the model numbers up and putting the same thing back in, shame on you. Don't do that.
yeah.
If you're a homeowner, don't accept that. If somebody doesn't do an actual load calculation on your home to say this is how much heating and cooling you need, and then go through the proper equipment selection procedures, they're guessing.
Yeah, 100%.
They may or may not get right. You don't know. There's no scientific backing for it.
And here's the sad reality is, like, even if they do a heating and cooling load calculation, unless you get that report and you know what you're looking at in that report, they can make it say whatever they want it to say.
Yep.
So it's again, unfortunately, you need to have some level of trust that the person that you're hiring actually knows what they're talking about and isn't just blowing you smoke.
Yeah.
So do a little bit of vetting, ask for referrals, that kind of stuff. Make sure that you've vetted them out. Luke had a follow-up to that. He says, sorry, he was talking about a dedicated dehumidifier as far as the split between latent and sensible load.
Oh, well, if you're looking at a dedicated dehumidifier, the way that we actually got bit in the rear in this, it hasn't been 25 years, so I can't mention the specific job yet. But we got bit. We fixed it, but we got bit because we went with an ERV on a 2-stage geothermal heat pump, and we thought that we were concerned this was like a 3,500 square foot house, if I remember right, and during the low load seasons, they were having moisture problems. So we had to yank the ERV out and actually put the dedicated dehumidifier in. And at that point, I don't know if there's anything written industry standards wise, but from our personal experience, what we found in Kentucky was if you were dealing with any type of a high performance home, anything that is like ultra insulated, low air changes, large amounts of insulation, just, almost like overkill, you need to really separate the sensible cooling, which is what drops the space temperature, from the latent cooling, which is what's removing moisture, because our shoulder seasons here are just, they can get nutty sometimes.
Yeah.
So then just let the cooling system do what it's going to do, and then let the dehumidifier do its job. And if the cooling system happens to be running, you'll get a little bit extra dehumidification out of it.
Yeah, this is his follow-up. So mention one of your classes. Best strategies to size the AC unit for the sensible and include a dedicated dehumidifier for the latent.
Yep, that's exactly what I'm referring to.
Yep.
Is you let them do their own thing, because if you're dependent on the air conditioning system, whether it's a heat pump or a straight air conditioner, whatever type of equipment you've got, if you depend on that system for dehumidification, it's going to run depending on whether the thermostat's calling for cooling or not.
Right.
And if there's no load in the house, then the thermostat's not going to call for cooling, which means there's no dehumidification. So handling those two systems separately, it does cost more money, but my goodness, the outcomes of it are so much better.
Yeah.
It's a great strategy, especially for high performance homes, whether they're, completely spray foamed or they're using something like structural insulated panels, insulated concrete forms, that's something like that. It's a great HVAC strategy for that, because then if the construction is done correctly, you can control the air changes in and out of that house mechanically instead of depending on Mother Nature to do it. And then you can ventilate because you've got control of the air.
Yep.
And dehumidify.
Yep. It's getting to the point now where it's really difficult to build a new house that doesn't have some kind of a dehumidification strategy. I mean, at least in our climate.
You just about have to.
I mean, because if you build it to code and it's been air sealed properly and everything, and the cooling load is, the AC is actually matched to the cooling load, which you know how often that happens. You're still going to have these shoulder seasons, right? You're going to have
Yeah.
these times of the year where you don't have much cooling load. You still need dehumidification. So that's a good question. So I've got another question from E.G. Kmeyer, sorry. And it says, we built a well-insulated house on a slab in Western Massachusetts. The first winter, we had tons of condensation on the patio doors as well as on the bedroom windows that had thick curtains. And then the follow-up is how to fix that. Do we insulate the slab, radiant? Oh, it has insulated slab, radiant floors, and one large ERV.
If you're getting condensation on those windows, that condensation is a good sign of how tight a house is during the wintertime.
Yeah.
So you may even need to increase the ventilation. If the house has not had a blower door test on it, that'd be the first place I'd want to know is how tight is this house? How much air is leaking through it at 50 pascals pressure difference?
Yeah. We had tons of condensation on the patio doors as well as on the bedroom windows that had thick curtains. So my question with the bedroom windows is, do you have the curtains covering the windows all the time? Because that will make the windows colder and more
Yep.
likely to condense.
Acts like an insulation layer.
Yeah, and we actually saw that over in Lexington recently. Clevenger called me about an issue with a house where they actually had the curtains covered part of the drywall next to the window,
Mhm.
and the register was basically blowing air between the curtain and the
Oh,
drywall and creating some microbial growth. So that's a good one. So she does have an ERV. I'm also wondering, is the ERV running in the wintertime?
Yeah. Is it because with it being radiant, you would need to know what the control strategy is for the ERV, whether it's set up manually, whether you control it, or whether it's set up off of a timer. There's multiple ways that you can set those up. It'd also be very interesting to know what the relative humidity is inside the home when those conditions are occurring versus what the outside temperature is.
Right.
And also
said-
what side less than 3 with the blower door. I guess air
I'm
changes
guessing-
per hour, I'm guessing.
I'm guessing that's ACH 50.
Yeah, which that's
fairly tight.
yeah, that's somebody did their homework on the construction of that. So well done.
Yeah. I mean, it's not a passive house, but so like
No.
Indiana's code is 3, I think now.
Yeah.
Yes, it runs. She did another follow-up. But we put one large one downstairs in the laundry room, kind of far from the main living space.
So it may not be benefiting that area.
Yeah. Does the ERV actually connect to the HVAC system and circulate through, or is it like an independent ERV? I guess is my question. So good questions. Slab. It says ERV. Yeah. Okay. Well, hopefully we answered that question for you. If not, pop another one in the chat. We got another one from Foresight Home Inspect. What are some options for air balancing when no balancing dampers were installed at the branch takeoffs at the time of installation, and or a majority of the ductwork is covered with drywall? That's a good question.
That's a tough one too. 'Cause number one, it's hard to balance a duct system that's unsealed. So I guess that would be number one. Is the duct system sealed? Because you can't control air unless it's first contained. So you'd have to have a tight duct system. If there's no access, the only other option that you have is you're going to have to do something at the boots themselves. A lot of times people will try to use the supply registers to do that, but you may end up with noise issues. But in order to do a true air balance, you really have to have the dampers at the trunks themselves and the branch ducts, which are the pipes that are feeding the boots.
Yep.
And so that way you can keep the air in the trunk. You might be able to do a comfort balance if you're having, issues with rooms that are too hot and too cold. You may be able to direct some of the air from the rooms that are getting too much to some of the lower rooms, but I don't know if you'll be able to do a true air balance.
Well, and the other thing I'm thinking is are we talking about a particular house, or are we talking about in general? Because if you were talking about a particular house that has like a comfort issue where one room's getting hotter or cooler than another room, then you also might have an issue where there's just not a pathway for the air to get back out of that room back to the common area. So whether you could put like a jump duct from one room to another, or a transfer grill to relieve the pressure from that room, instead of actually balancing the ductwork. Like there's kind of two different approaches to this, right?
Yeah.
So if that would be one thing to know, like, do you have a pressure gauge and a manometer where you can actually test with the HVAC system running, put the hose underneath the door with the HVAC system running, you're standing in the common area, and see what the pressure difference is between the bedroom that you're talking about, or all the bedrooms, and the common space? Because if that room is negative or positive more than a few pascals, then you probably need to put a transfer grill or something to relieve the pressure when that door is closed.
Yep.
Obviously, you can keep the doors open and it will fix that problem by itself. But a lot of people just keep their doors closed all the time, especially if they got teenagers.
Yeah, for sure.
Let's see, we got another one here. Actually, Pierre had another one up here further up. Let me go back up here. How do you do a proper heat load calculation when using a blower door? Well, a blower door is only one piece of a heat load calculation. And there's a lot of different software out there to do heat load calculations. There's some really cool ones now that you can use where you can basically scan the house with an iPhone or an iPad Pro, and it does uses the LiDAR camera.
Yeah.
And so like Conduit Tech, Quick Model 3D, I think Amply Energy is another one.
Yeah, Amply's another one.
And so you can scan the house with these devices in the software program, and then use that blower door number to put into that software, because otherwise they're just going to say, is it leaky? Is it average? Is it tight?
Yeah.
But it's not actually putting a quantifiable number in there. So that's,
It will increase the accuracy if you can get that number.
yeah. Or if you have a heating cooling contractor that you work with on a regular basis and they don't have a blower door, do the blower door for them, have
Yeah.
them do the heating cooling load calculation so that you don't have to take classes, because it does take time, but using some of this software makes it a lot faster and more convenient. And then he says, what does a poor heat load calculation look like versus a good one?
That's if it comes, I guess probably the simplest and quickest way to look at it is, if it magically comes out to 500 square foot to the ton, it's a poor load calculation. It's because somebody has fudged the numbers to try to fit what they're comfortable with.
Yeah.
Also look at there are a friend of mine out in Texas, Paul Wiebolt. He runs, I think, manualjddesign.com, but he actually teaches how to go in and do load calculation post-mortems. So to go in, investigate them, and find out where the errors are.
So he gets the report, and he goes through the report and looks at all the numbers. And
yes. And he can, pick it apart.
Yeah.
So if you've got a bedroom that's got 20 people in it, yeah, you've probably got somebody's fudged some numbers.
So, obviously this is more than we can talk about in the next 10 minutes, but like it takes, you can do classes that are days long, weeks long. Like it takes a while to really know how to do a good heating cooling load calculation, but it comes down to garbage in, garbage out. So like if you're able to at least read the basics on that report, like does the square footage of the house in the report match the square footage of the house in reality? Is the volume calculated properly? Does it have like the proper amount of surface area for windows and doors? To David's point, do they have 20 people living in this house when there's only 3 or 4 people?
Yeah.
Because all of these things affect the load that the software is giving you. So it's a great question. We have another question here from Modern Comfort CT. When using a blower door, you are getting your infiltration for the dwelling. When not using a blower door, you can use one of a few set infiltration factors. So having the blower door is more accurate.
Spot on.
Yeah, I guess it wasn't really a question, just an add-on to that.
Yep, spot on.
Yes, sir. All right, let me see. We got 10 more minutes. If anybody has questions, pop them in the chat, and I'm going to check my email and see if anything else has come through.
While you're doing that, I do want to make another comment about the ventilation strategy.
Okay.
One that is code compliant, but you should absolutely avoid is negative pressure or ventilation only, like using a bath fan running nonstop. I know
100%.
both of us dealt with moisture issues. I know we talked about it on one of your episodes
Yep.
with moisture issues. And anytime you get in a mixed humid climate or humid climate, it's even worse because if that fan, depending on how it's set up, if it's running nonstop, it's pulling air in from somewhere. And
Yep.
it's usually places that you don't want to breathe, but it's also usually loaded with moisture and it's going to cause all kinds of humidity issues. So if your ventilation strategy is to put in some type of a bath fan, regardless of how quiet it is or how efficient it is, and run it nonstop, it's not going to be your best choice.
Yeah, that's an understatement for sure.
Yeah.
And that is the soup du jour for production builders. I mean, this was a good part of the last conversation we had last month. Um, and that is like in Kentucky and in Southern Indiana, most large builders will use that strategy, and it depressurizes houses depending on how tight they seal the house. So a very well
Yeah.
air sealed house with an exhaust only ventilation strategy is going to depressurize. In the wintertime, it's going to pull in cold air, cold, dry air. And in the summertime, it's going to pull in very humid, hot air. And so, if you've got, we talked about the dry line sheathing that a lot of these builders use instead
Yeah.
of OSB or plywood.
Yep.
It's dry line. There's a couple of different manufacturers, different names of it, but that really thin sheathing. If you've got a newer house that has that really thin sheathing on it, and you've got especially like a walkout basement where they didn't put drywall up on the framed and insulated part of that walkout basement, that interior part of that sheathing will get really cold because the humid, warm air inside the house will go through that fiberglass
Yep.
or cellulose and hit that really thin material, and it'll condense on the interior side. It can start sweating. If it's cold enough, it can freeze and it can frost. So it's definitely not the best way to go. Let's see here. Another question is, how does static pressure testing work in layman's terms? So I
Great question.
assume we're talking about testing HVAC systems and ductwork.
That'd be my guess. It's
Yeah.
the easiest way to think about it. You go to your doctor for a yearly physical, and they're going to take your blood pressure. Static pressure is nothing more than the blood pressure of an HVAC system. It's a good reflection of the overall health of the total resistance that the blower inside of a forced air heating cooling system has to work against. So it's how
Yeah.
much it has to push and pull air against. It's a great diagnostic tool because if you have high external static pressure, there's pretty good chances that you have one of a couple of scenarios going on. The most common is you have restrictions in the system. The second one, which is the least common situation, is that the blower motor is set up incorrectly as far as its speed. If that's the case, that's an easy fix.
Yeah.
You get the right amount of airflow, the pressures come into line. It's a good day to be you. If it's the first situation that we talked about and there's restrictions, whether it be a filter or the cooling coil or the ducts themselves, then additional tests using the static pressure measurement can help you identify where the restrictions are.
Yeah. He says, I thought low was good, but I don't really understand it very much. So, I mean,
Uh,
lower pressure is better.
It is if the ducts are tight, and that's one of the things about low static pressure is it can fool you. If the ducts are tight and the system is clean and airflow set right, then yes, it could be a good thing. But it could also be an indication that the blower is dirty. It could also be a sign that you've got disconnected ducts that have fallen apart. So it once again, that's like a lot of the things that we've talked about. It does depend. There are
Yeah.
situations that you could have low static pressure that are great, and you could have it where it's low and it may not be good at all, depending
Yeah.
on the installation and system condition.
This actually happened at my brother's house. I was visiting him. He lives in Arlington, Texas, and I had told him, you need to seal up the ductwork, whatever. And he bought a manometer, static pressure probes, but he hadn't actually tested the system, and it was a great opportunity. I was like, "Hey, I'm here for the weekend, so let's get up in the attic." And I'm testing the return side of the system, and it is so low. I'm like, "This doesn't make any sense. Like, it's not
Mhm.
even registering." And so I followed the flex duct that was connected to the return plenum, and I go back and look down, and the original builder had put the flex duct into a piece of sheet metal and panned it into the ceiling, but it was wide open all the way around the perimeter
Oh,
of it.
wow.
So it was drawing in air from the attic probably more than it was drawing it from the cavities below
Yeah.
that it was connected to. And I was like, oh my God, bro.
Yeah.
Like, you got to get some sheet metal and some duct mastic and go to town here and then retest it and call me back.
The other thing to be aware of is if somebody's static pressure measurements are always low and they look great, one of the most common problems is testing in the wrong locations,
Mm,
and that can cause your readings to look too good to be true. In addition to that, so there is the assumption that whoever the tester is measuring in the right spots.
yeah, that's a great point. So we have, let's see, another comment here. Are there any studies or knowledge on how much sooner high static pressure causes an ECM motor to fail?
I can't remember if it is LSU or Texas A&M. I think there was a research paper that they had done about it, but I could not pull it right off the top of my head. And I do know some studies that we've done at NCI have actually correlated airflow and static pressure and what the averages of that run. But as far as longevity of what an ECM is an electronically commutated motor,
Yeah.
Commonly known as a variable speed motor. But what happens is when external static pressure goes up on a HVAC system blower like that, that motor tries to move its programmed airflow, and it will speed up, and it pulls the amount of watts that it pulls to do that, or power that it pulls to do that increases substantially. And with that, it also creates a tremendous amount of heat inside that motor, and it can't dissipate it fast enough. So the electrical components inside of it they fail.
Yeah.
So if you've got a piece of equipment that has a ECM blower or variable speed blower and it's like really loud, there's a good possibility it's trying to work against very high external static pressure to move the right amount of airflow.
Yeah, and that's a common complaint with people who replace older pieces of equipment with new modern equipment that has the variable speed. It's louder than it used to
Yeah.
be. My electric bills actually went up. They're higher than they were before.
Yes.
And again, this goes back to like properly sizing the system, for the house, but also to the duct system. Because if the ductwork was already too small to begin with, and now you put another system that's too big on it, and it's trying to ramp up, it's just, there's a lot that goes into heating and cooling sizing
Oh yeah.
and duct sizing and all this kind of stuff. And at least in the Midwest, there is an epidemic of undersized return ducts in pretty much every house that I've been into. Like, it's really rare to find a return duct system that is properly sized for the equipment that's there. So you can never really have too much return air going back to the equipment. Like, you
Nope.
can oversize that as much as you want, as long as you have the space to put it. So the other problem that you see a lot in these larger production built homes is they don't have enough space for the equipment and the ductwork. So they give you a small closet, and
Yeah.
it's not the HVAC guy's fault, but he's got a small amount of space to work with. The return drop's coming down, and the water heater's right next to it, so he's got to squeeze this. So it takes more forethought, is what I'm saying.
Absolutely.
Let's see. I got one more question. This will probably be our last one. Does it make sense to replace a 35-year-old furnace, but not the 35-year-old air conditioner? Should they be done at the same time?
If it's 35 years old, it's been a great install. I would do them both at the same time. I would not risk doing that because things are going to change. So I would definitely, if both of them are 35, it's awesome. That's been a well operating
Yeah.
piece or equipment hookup.
It has outlived its expected lifespan,
Yeah.
for sure.
That's
I
been a
mean,
good one.
So, like, to that point, like, a new air conditioner should last 15 years, 20 years if it's installed
Every
well.
bit of it.
Yeah.
Every bit of it. Now, if you're replacing a compressor within 5 years, you got problems.
Yeah.
Or unfortunately, sometimes sooner. There's other stuff going on.
Yeah.
That's one of the challenges with HVAC is because it's a built up system. It's not like we talked about buying a refrigerator earlier. It's not field assembled at a factory under controlled conditions. It's up to the installing contractor to do it right. And if they do a great job, then you'll get a great HVAC system. If they do a bad job, you'll get a bad HVAC system.
100%.
And sometimes the results don't show up right away. Sometimes it may take 5 years, unfortunately.
Yeah. Well, David, we're about at the 1 hour mark. I really appreciate your time today. This has been fun. Appreciate
Yeah.
all the comments from people chiming in here on YouTube. And we're going to plan on doing this once a month here going forward to provide value for you guys. So we'll just, check your email and I'll post it when the next one's going to be, but probably middle of the month sometime. It's, kind of up to David's availability here, but we're going to continue doing this, and I had a good time. And this is from our friend Derek. He says, great to be here. And Derek, I will see you here in a couple days out in Montana.
Awesome.
So David, I appreciate your time again, and we'll check you out on the next one.
All right. Thanks, Eric. Take care, everybody.
See you.